Welcome to the AI Infra Not 7 channel. Today, I see many infrastructure engineers and SREs asking the same questions. What exactly are GPUs? Do I really need both CPUs and GPUs? And will GPUs completely replace CPUs in our servers? Let's clear this up together. Let's learn. Before we compare them, let's look at what a CPU and a GPU actually do separately. First, let's talk about the CPU. Think of the CPU as the main brain of the server. It runs the operating system and manages all the system hardware. The CPU uses serial processing, which means it focuses on handling complex logic tasks one after another in a sequence. Usually, traditional Intel and AMD CPUs used in data centers have between 4 and 64 very powerful cores. Next, let's look at the GPU. The GPU works as an accelerator. It takes heavy mathematical workloads away from the CPU to speed things up. Unlike the CPU, a GPU uses parallel processing. This means it executes thousands of simple calculations all at the same time. To handle these massive blocks of data, an enterprise GPU, like those made by NVIDIA, contains 3,000 over 10,000 smaller, specialized cores. In short, the CPU handles the operating system and general tasks, while the GPU handles massive data and parallel processing workloads. The CPU acts as the manager, assigning these intensive tasks to the GPU. This specific teamwork, using a specialized processor like a GPU to handle the heavy lifting, while the CPU manages the rest. To make it easy to understand, let's look at traffic example. Think of a CPU as a single-lane highway. It's perfect for standard traffic, but heavy volume creates a bottleneck at the toll booth. A GPU, on the other hand, is a massive, multi-lane highway designed to process thousands of cars simultaneously. For a real-world example, look at the right side of the slide. Applying a simple color filter to a 1-minute HD video using only a CPU takes 30 to 45 minutes. A GPU crushes that exact same task in under 1 minute. But remember, this massive speedup is strictly for parallel processing. A GPU will not replace your CPU. You still absolutely need the CPU to run your operating system and manage standard tasks. Now let's talk about real-world use cases. The latest data center CPUs, like the Intel Xeon 6, are perfect for running standard middleware or relational databases, like Oracle, in banking and retail. For these traditional workloads, CPUs are really all you need. However, for machine learning and AI, you need enterprise GPUs like the NVIDIA H100, H200, and B200 for heavy training and inference. The resource requirements are drastically different. While a traditional CPU server might only need 128 gigabytes of total system memory, AI workloads require hundreds of gigabytes of ultra-fast memory per GPU. Because they deliver such massive parallel performance, these GPUs are very expensive, highly power-intensive, and require a complex hardware stack to operate efficiently. Note, prices and other specifications mentioned may vary, as this information is based on publicly available data from the internet. CPUs and GPUs offer two different types of processing power, chosen based on your specific requirements. One thing is clear, the CPU isn't going away. GPUs are simply an addition needed to power the new AI era. As you can see, the CPU market is led primarily by Intel for servers, desktops, and laptops. Conversely, the GPU market is a near monopoly held by NVIDIA, though competitors are quickly evolving their chips to meet soaring AI demands. To summarize, CPUs handle serial processing and remain essential for operating systems, databases, and web servers. GPUs handle parallel processing, perfectly suited for machine learning tasks, like fraud detection and banking, and running the intensive AI training and inference behind models like ChatGPT, Gemini, and Claude. I hope you learned something new today. Thanks for watching the AI Infra Not 7 channel. Happy learning!